Hello, everybody. Okay, so we have, oops, let me switch this around. So we have started the Desmos investigation together, but this is the full solution today. So um, Part of our stuff is all written out. You just need to go back to the video from the day before, which you can still access, and you'll see how I did each of the first parts. So in step one, we said that each of these were even degree. Wants us to graph them. We graphed this one. So now we're going to graph y equals 5x fourth minus 8x squared plus 2. Okay, and so I'm going to click on, I'm going to zoom in to Desmos a little bit, and I'm going to click on each of these points so I know that the y-intercept is at 0, 2, and I'm going to mark these out so that they're a little bit, so this is going to be 1, this is going to be 2, so every 2 tick marks is going to be 1 unit, because this is pretty compact. -1, -2, -3. Okay, so like that. And so I'm gonna have a y-intercept at 0, 2. Let's see, my x-intercepts are kind of weird. Let's see when these are. Well, we're gonna go ahead and mark them. So a little bit past -1, I'm gonna have an x-intercept. Then a little bit smaller than -1/2, I'm gonna have one there. And then it's symmetric. So I should have the same sort of thing on the right-hand side. Okay, and then on each of these, I should go down a little bit past -1. -1 is there. So I'll have a point like here-ish and there-ish. Okay, and so my function should go like this. Okay, so it doesn't have to be perfect, but I want you guys to label some stuff. All right, so there's that one. And then y equals 3.5 x to the 6th minus x squared minus 3. Okay, I'm going to zoom out so that I can see all of this stuff. It looks like I have intercepts at a little less than and then bigger than 1 on each side. I'm going to do the same sort of 3 thing. This is going to be -1, +1. Let me zoom in so you guys can see these graphs. Sorry, guys. Okay, give it a minute. And then I'm going to go down to 4, -4. So 1, 2, 3, 4. Down here, -1, -2, -3, -4. Okay, so this one is going to be right here, and we're going to have one right there. And then let's look at these points and what they are. 0, -3 is my y-intercept, which is super nice. And then these values are a little funky. But they're about here and there. So our graph, is going to look like this. Okay. All right. So I'm okay if you don't label them, but at least like put points where they are on your Desmos graph. And again, if you click on them or hover over them, Desmos will highlight them for you so you can see. Okay. So that's that. Now we should focus on the questions. It says, what do you notice about these graphs? What do they have in common? So the thing that all 3 of these have in common is that both of their endpoint arrows, or arrow ends, I guess, go up. So both, that's not how you spell it, both end behaviors go up. Or you could say towards positive infinity. Okay, that's, let's see, sorry. Let me zoom out a little bit so that you can see. This is both what they have in common, and it answers both of those questions. Okay. So I said both end behaviors go up, and they go up towards positive infinity. Okay. The end behavior of these graphs is going to be up or increasing left and increasing right. Okay, I'll accept also if you write up or towards positive infinity or something like that. Both of those would be good. Then it says, change the leading coefficient to be negative. What does that change about the graph? So had I been smart, I would have left all three functions into Desmos and then just changed the negative coefficient, but I didn't. So here we are. So if I make that negative, is that really? All it does is flip our function so that it's going down. We can see that with the next one as well. So we'll have negative 5x to the fourth minus 8x plus 2. And this one also now faces down. Okay. And the last one is also going to do the same thing. All right. Let's see. We're going to have negative 2x squared plus x minus 1. Okay, so it switches it so that it's facing down instead. So what does this change about the graph? It makes both ends go down or decrease or go approach negative infinity. Okay, so any of those three things would be totally fine. Okay. All right, so then for step 2, it gives us all of our odd degree functions. First, it asks us to graph them. So I'm going to get rid of these even degree functions, and I'm going to type in my odd, and this time I'll leave them in there so I can just switch them to negative. So minus 5x. Okay, so here is our middle function. Again, we can highlight our intercepts and mins and maximums to be able to accurately draw this on our graph. And so I'm going to put a point at 0, 0. A point, I'm going to make my scale the same as the last time with my value for 1 being 2 little squares. So I'm going to have a point here, and it goes up here, maybe, and then down here, 1, 2, 3, and then my intercepts are going to be a little past 1 here, a little past 1 there, and we have a nice function that goes something like this. Okay. And then the last one, okay, so the middle one is our black function right there. And then our last one is going to be y equals 0.5 x to the 7th. It's kind of badly formatted on this document. I'm very sorry. And then plus 3. Okay, so this is our red function. I'm just going to unhighlight this one so that you guys can only see the red one, the last one that I did. And this one has nice points. Okay, so I'm going to plot, here's -1. So I go past a slight amount past -1 to plot my x-intercept. I go up. So this is 2, 3 for my y-intercept. And then a little past 1 on this one. And then like about 1.5 right here. Okay, so this function is going to go like this. Okay, so just make sure you're plotting and labeling your axis so that I can see. Then this one asks, what do you notice about these graphs? What do they have in common? So notice that their ends go in different directions. Okay, so on the left, it's going down. On the right, it's going up, down, up, down, up. What do they have in common? All of them start down. So the left side, that's